Alright, here we are. We're going to be doing the angle addition formulas. And so I have them written out here. Sine, cosine, cosine, sine. Cosine, cosine, sine, sine, sine. So from some teachers in your past, you may have learned sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. And this is how you memorize it. If you look online, there's going to be a bajillion teachers who are all saying this chant. The thing to remember here, and this is important, is that this negative needs to be there. So, here's one example. Oops. Why would we use this? Okay, so let's try doing the sine of 75 degrees. Okay, so sine of 75 degrees is not on the unit circle. What we do then is we think, well, I do know two angles that are already on the unit circle that will add up to 75. So in this case, it would be 45 degrees and 30 degrees. Okay, and then because it's sine, we're going to be using the sine formula. Sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. Alpha is going to be 45 and beta is 30. So sine of 45 cosine of 30 plus cosine of 45 sine of 30. All right. Now what we need to do next is just evaluate, because we have 45 and 30 on the unit circle. Sine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2, and these are being times together, plus cosine of 45 is root 2 over 2. Sine of 30 is 1/2, and those are being multiplied together. All right, and now we just simplify. So we're going to have root 6, because when you multiply radicals, you can actually put them together as long as they're in the same kind of radical. So that's all over 4, and this will be root 2 all over 4. So most textbooks will write the answer as root 6 plus root 2 all over 4. And to get an idea of what this means, the unit circle looks like this. This would normally be 45, and this would normally be like 60. 75 is like right up here. And so if you were to evaluate this decimal, it would be really, really close to 1, because as we go this way, our sign is getting closer and closer to 1. And so let me pull out a calculator here, or I can pull it up actually on my computer. If I do 2 rooted plus 6 rooted, and then divided by 4, I'm getting 0.966, really close to 1. Anyway, we could do this with a lot of different things here. I want you guys to try this now, cosine of pi over 12. Now I'm going to help set you up here, because pi over 12 is actually going to be less than 30 degrees, or pi over 6. So pi over 12 is going to be like right there. Okay, and guys, you can have negatives. So try this. Try evaluating it with pi over 3 minus pi over 4. Okay, you would want to pause the video here. First, you should check and see, why is that equal to pi over 12? And then you should try to find the actual cosine using the rule. Okay, so here's what you need to do. Think of this as alpha and this is beta, and be careful because beta is negative pi over 4. So this is actually going to be cosine, cosine, sine, sine, sine. Cosine of pi over 3, cosine of negative pi over 4, minus sine of pi over 3, sine of negative pi over 4. Okay. And then cosine of pi over 3 is going to be 1/2. Cosine of negative pi over 4, if you're thinking about the unit circle, that's down here. That would be root 2 over 2, minus sine of pi over 3 is root 3 over 2. And then sine of negative pi over 4 is going to be negative root 2 over 2. All right, so we have root 2 over 4 here. And because of the minus minus, we would have a plus there. And that would be root 6 over 4. Okay, so this happens to be exactly the same as what we got before. Now the idea is that, remember that at 30 degrees, like sine is 1/2, at 60 degrees cosine is 1/2, and there's kind of some symmetry there. It's the same thing with pi over 12 and 75 degrees. Those guys have symmetric sine and cosines. So there we have it. Be careful about your negatives and your positives. One other thing, tangent also has an alpha plus beta rule. It's not used quite as much, but you still need to know it. Tangent of alpha plus tangent of beta all over 1 minus tangent of alpha tangent of beta. Okay, so we're going to do one of these, and you have to be persistent, because let's say we wanted to do tangent of pi over 12. We already know that this is the same as tangent of pi over 3 minus pi over 4. The hard part is not plugging in the first two numbers. The hard part is simplifying. So what this will be, first of all, plugged in. I'm writing out all my work here. Oops, I'm sorry, that should be a minus. Tangent of pi over 3 and tangent of negative pi over 4. Okay, tangent of pi over 3. We got to go back to our unit circle with tangents. Pi over 3 is actually root 3. Negative pi over 4 is negative 1. So tangent of pi over 3 again is root 3 times negative 1. Okay, this is not the hard part. We have to now simplify. So we could rewrite as root 3 minus 1 all over, and then this would be 1 plus root 3. Okay, and nothing cancels here because you don't want to split up binomials there. You can't. And so one way to do this is to multiply by the conjugate of the downstairs. We're basically rationalizing. Okay, so on top you have root 3, you have negative 3, you have negative 1, you have positive root 3, and on the bottom you have the difference of squares. So that's going to be 1 squared minus root 3 squared, which is 1 minus 3, which is negative 2. And I'm going pretty quickly, but if you need to, write this out more. When in doubt, write it out. Alright, so I have negative 4 plus 2 root 3 all over negative 2. And now I can finally do the butterfly. So this would be positive 2 minus root 3. Okay, so again, the hard part is not exactly plugging in the things. The hard part is simplifying.